sunset from 4 p.m. to 6 p.m. Those are the higher the times when the beetle is really flying. And this is important if somebody is going to do any type of control, such as chemical control. Opposite to other beetles that regularly are nocturnal. After 7 p.m. you don't get this species, you start getting different species. So this is the behavior of this beetle is a little bit different. Other thing that we have noticed is during cloudy days, there is no beetle emergence. If there is a sunny day, and as soon as the sunset, the star appearing, then there is a reaction and the beetles proceed to emerge. And it's not showing really well, but basically what we did here was to put clear plastic traps with a sticker material, and we observed different heights of to see where much height or altitude the beetles were flying. Mostly they were flying mostly really low, but that doesn't mean that they can fly up to 20 feet above the ground. But most of them, the flight is really, really low among the really low areas. This is just to show the different flights that the beetle has, approximately 6 flights to the year. And at that time, this perhaps occurs the major dispersion. And most of the peaks occur between March and April. Again, this is under Florida circumstances. The different hosts in the USA are, most of them, all of them so far, are in the Laurel, one of the Persea palustris, that has a distribution in the southern states of the USA. The other one is Persea humilis, with most of the distribution is in Florida. So I think that's what is going to congregate in one part of Florida. Persea borbonia is spread from Delaware to southern Texas. You saw in the grand slide that there is data that they have been found out here around Mississippi. So depending on, I expect that the beetle will continue that pattern of dispersion. And this is the damage in avocado, and again, with the areas that would be affected would be Florida, Texas, and California, in the USA. So far we have tested around 23 different cultivars. All of them have been borne by the red bay ambrosia beetle, but they differ in the reaction to the disease. Some of them appear to be more susceptible than others, and I can talk about that. Thanks to colleagues here in California, we obtained bolts of all different Persea species, and we exposed them to the beetle in the laboratory and also in the field. And all the species of Persea were born, with the exception of Persea flucosa, that calls our attention, that this species doesn't appear to be very attractive to the beetle. We still need to repeat this once more to see if it will continue repeating or not. So I think this species will be something that we should pay attention. Because of requests from here, what we did was to obtain logs from California bay laurel. We exposed them in hammocks where the red bay ambrosia beetle was present. And the interesting thing is that California bay laurel was more attractive or more bored than avocado. At that point, I think the reason is that this was a red bay hammock, so the bolts could not compete with the red bay, but California bay laurel obtained approximately 2.5, an average of 2.5 entrances per bolt. Two of my colleagues, Paul Kempla and Walt Mayfield, have repeated these experiments, and they have corroborated that in the lab and also in the field, California bay laurel can be borne by the beetle. So to summarize, all of these Laurel have been borne by the beetle. Some of this data belongs to our from other publications, and this is from our publication, the same with California. What we have done is going to the areas, one of the areas where the beetle was what is originary, that CAAvoGrowers one. And we went to forests where we found approximately 40% of Laurel species. We placed logs of those species in the forest, sometimes in bundles on the ground or hanging from the tree. Fortunately, from those settings, we didn't collect a single red bay ambrosia beetle. However, when we went to a different site where there was a collection of cinnamon osmofleum, another lauriacea. We observed that this was previously damaged by other insects, but on those we found the red bay and Russia beetle. So far, from all those hosts that have been reported in the literature, we only found it in one beetle. Again, these were for a few weeks of conducting this survey. Perhaps other people will do a more extensive survey. Another thing that was interesting when we were doing this survey was in the collection was in the osmofleum. The only trees that they were cultivars that they were what we found galleries of the beetle and we extracted adults of the beetle were those that were attacked either by termites or by longhorn Russia beetle. So in that case, that could be that the beetle is acting as secondary, and that calls back my attention to something that a colleague of mine, Gary Moser, said that when the beetle in Asia has co-evolved with this species of Lauraceae, so this Lauraceae can tolerate this fungus and then they won't wilt. When the beetle arrive here to the USA, this, the species that is attacking is what is called naive species. So these ones are not prepared for the attack of the beetle or the attack of the disease or the problem with the pathogen. So that's something to take into to think about. We are working with attractants as well as repellents. With attractants, the goal is to find a really powerful attractant to bait and kill the beetle, and the repellent, the name says it, is to avoid that the beetle comes in contact with avocado. My colleague Paul Kendra is working mostly on volatiles or compounds found in trees, and he's working with mostly he has found that this compound, alpha-tocane, which is present in lychee, in avocado, and guava, is one of the major attractants for the red bay ambrosia beetle. This ambrosia beetle is being bait using this trap, using a bait which is called manuka oil that comes from the manuka tree. But this bait is very, very weak. There is another bait more powerful that comes from the phoebe tree, and it's called the phoebe oil, and that's very rich in alpha-tocane. The problem is that phoebe oil is not available in the market anymore. So what he's doing is trying to find sources of alpha-tocane, and that is one of the goals that he has to introduce that into a bait that we will use. Another colleagues, Stelinsky and Moser, are working with compounds produced by the fungus to see if they will attract the beetle. And here's just an example in an olfactometer. They put the different fungi, put the beetle here and the beetle, and the beetle will go to where the fungus is, or will be repelled by another fungus. And in this graph, you can see these were the ones that I found as attractant. These were fungus, Ambrosiella, Ambrosima, and these other ones were antagonists. So, for repellents, we have been working with what is called beetle block that is used against other beetles in pinelands. And this gives very, very interesting results. These are, this is how we bake the logs. It's a sachet that contains the very known beetle block. And in this case, you can see these were controls, and this is when we place the sachet close to the log. And this is okay. What we are using, we are at the really low ambrosia beetle densities, but when the densities are more than 20 entrance holes per log, doesn't seem to be very effective. So we really need to work in dosification of these sachets to see the power of repellents. Aside of that, what we have done is to test trees that are found in the Florida, in those hammocks with red bay and swamp bay. And we have tested different species of pines, oaks, cypress, cedar, elms, and others, and see if they are non-hosts or hosts of the red bay ambrosia beetle. And only two, we found that the beetle is able to bore into it. One of them is the bone apple, and non-cloud, and the other is called cypress. What is going to be interesting is to see which volatiles are produced from those compared to the ones from the other non-hosts. What Stelinsky is doing then is taking some of this data and taking parts of the semi-species that I'm working with, and he has found out that the following trees